What are stacks and queues? Let's look at it together. So one good example for a stack is from our daily lives actually. So let's think of a surface here. Let's say this is our desk and we start putting the books. Book number 1, book number 2, book number 3 and book number 4. So when we approach and grab those books, which book do we take first? We take first the book on the top, which is the last element we put, right? So the technical term is actually quite simple, just like what we said, last in, first out principle. So stacks work with last in, first out principle. So stacks are dynamic arrays. Push and pop are important terms. They are insertion and removal. And we will see that in an example in a second. So it will make more sense when we actually code it. What about queues? Queues are the opposite in terms of last in, first out principle. So it will be first in, first out. Let's see why it is the opposite. So let's say these people are in line for the bank. So this is the teller. And this person came first, this person came second, this person came third, and this person came fourth. Which person is going to leave the bank first? This person, right? So which means first in, first out. Whichever person came first to the bank will leave first. So let's write it down, first in, first out. Queues, on the other hand, are implemented as linked lists. What is a linked list? Linked list is an array type structure. However, at this time we have relationship between the elements. So the terms that is good to know here is that Enqueue and dequeue. These are the terms we use for insertion and removal. So what did we say? Let's sum it up. Let's sum this up with a different color. Stacks are working with last in, first out principle. Queues, on the other hand, are working with first in, first out principle. So example of a stack on a question, on a problem, could be a min stack problem, which stores the minimum value. An example of a queue in a problem could be a priority queue. So let's talk about the time and space complexity for this. So for both of them, both of these structures, inserting an element, removing an element, and picking an element. What is pick? We are actually not inserting or removing, we are just taking a peek to the element. Takes constant time and constant space operation, unless you are storing a really large stack or queue. Searching an element, on the other hand, takes linear time. Why linear time? Because we are visiting each and every element of the queue and stack to search for the element we want. And what is the space? It is the constant space. What about storing? So I'm running out of space, so I have to write storing here. What about storing a queue or stack? Storing takes also band space. So let's go ahead and write these in a code, so it will be making more sense when we work with the code itself. Let's start with stacks. So following the example we give is that my books, we said stacks are dynamic arrays. So I'm creating an empty array here. And what I'm going to do is I'm going to push, which is insert elements to my array. So what I'm going to do is I'm going to use append function. So let's number the books. We are going to append 1. Then, excuse me here. We are going to append 1. We are going to append 2. We are going to append 3. And we are going to append 4. Let's say that we have these 4 books in the array. As we see that they are 1, 2, 3, and 4. So let's pop one of the books. Remember the example we looked at? We grabbed the book that was at the very top. So for that, let's name it pop equals my books dot pop function at this time. So when we do that, we will have pop equal to 4, and at the same time 4 will be removed from this array. So as we see that our pop is now equal to 4, which is the book 4, and then 4 is removed from the array. So we just grab the book that was at the very top. So this was a small example for a stack. Now let's talk about the queue. So I'm going to go ahead and import a library called queue here. And then let's start our queue. My queue is equal to queue dot queue. So I'm creating a queue using the queue library. Okay, so after that, let's start inserting elements to my queue. So my queue, this time we will use put. In the stack example, we used append. Here we are using put. So let's copy this, and we are going to go ahead and insert 2, insert 3, and insert 4. And remember, these were people's numbers in the bank. And the first person was numbered as first, which was close to the teller. So let's get the first person. First person will be what? My queue dot get. So get the first person. And let's go ahead and run everything here. As we see, first person is equal to 1 here, which arrived the first. So let's remember, this will be first in, first out principle for the queue. So these were a quick example of a stack and a queue.